Right. I also wanted to spend a little bit of time talking about the mechanics of the course itself. Um, so all of the lecture material is going to be available online. This will be presented through Canvas. The plan is to release video and homework assignments at the beginning of each week, and then you'll have that week to work through the videos, ask questions, and work on the homework assignments. We do have an assigned lecture time, and what I'm going to do is use that time period for my office hours for this class. So this is Tuesday, Thursday, 9 to 10:15 in Sarkeys. We'll also live stream that via Canvas if that's something that those of you who are coming in from outside the OU campus would like. We also have a TA for the course, and she will be choosing her office hours at some point in time. We're going to try and make sure that we're accommodating everybody in the class, so making sure that we have office hours such that everybody has an opportunity to get the help that they need. All of our homework assignments will be done in Python. As we talked about already, we're providing a computing server for you to do these in. We'll be using the Jupyter Lab IDE. And the nice thing about the server is that packages are pre-installed, and then we'll also have our data available there, and our code skeletons will be automatically available to you. And of course, you're welcome to work on your local machine if that's what you wish. What I'm assuming about you. So first off, I'm assuming a background that includes programming experience. So in particular, you should have experience with some object-oriented programming language. So this could be Python. Many of you are coming in through having Java or C++. Python doesn't have to be object-oriented, but the packages that we're using, especially scikit-learn, is very heavily object-oriented. We'll spend a little bit of time here in the next couple of lectures talking about how to use objects, how to implement objects. So don't worry if you don't know the mechanics in Python quite yet. I'm also assuming that everybody has a background in statistical methods, and in particular, you know what linear regression is, and you know how it works. And then we're also going to be making use of hypothesis testing. This is going to be really important as we're getting into this problem of how do we compare the performance of different kinds of algorithms for particular problems. All right, so resources. I do have a course webpage. The URL is given there. That's linked from Canvas. Within Canvas, we will also make use of the gradebook. Announcements will be up there. We'll make use of the discussion board and information like office hours, the syllabus, and all of our videos, of course, will be posted to Canvas. The text that we're using is hands-on machine learning with scikit-learn and TensorFlow. We'll use the first 9 or 10 chapters. The 2017 version of the book is available right now. There's a brand new version coming out. It was supposed to already have been out, but it has been delayed until the middle of the semester. So we're dropping back to the 2017 version. We'll also make use of a variety of web resources, so documentation for the various packages, in some cases some tutorials, and as necessary we'll also link to some papers as well. All of that information will be linked either from Canvas or directly from the semester schedule page. All right, so this is a very practical type of class, and it's designed for this online type of environment. So we're going to be doing lots of homework over the course of the semester. So just about every week there will be a homework assignment. We'll also do a test assignment at the beginning of the semester just to make sure everybody has their Jupyter system set up. And for the most part, those will be 1 week. There are a couple of them that we have in mind that will take a little bit longer. These assignments will explore different machine learning methods and data sets. And we'll be looking for a couple of different things. Of course, we want you to be successful in solving the prediction problems, the visualization or statistical method problems, but we're also interested in the quality of the code that you're generating. So is it doing things in reasonable ways, and is it documented? There is no final exam, and there is no end of semester project. So your grade, the end of the semester, will be based entirely on those 12 assignments, plus one. As far as academic conduct goes for the homework assignments, I'm expecting everybody to be doing those on their own. So there must be no communication of solutions with anyone other than me or the TA. You should also not be copying code off the net. General communication amongst you students or drawing inspiration from the net is fine. But when it comes down to actually implementing a solution for the homework assignments, this needs to be your own work. All right, being successful in the class, some of these hopefully are obvious, maybe others are not. Of course, we want you to keep up with the lecture and the homework assignments. Homework assignments will have specific deadlines, so you need to make sure that that you're getting the reading in and the lecture viewing in before those assignments are due. You also need to get used to reading the documentation. One of the nice things about scikit-learn is that the interface is very consistent and the documentation is quite reasonable. In general, the assignments are not going to be doable within a day. These are things that you should plan on spending a couple of days on. Maybe the first couple will be easier, but as we get further in, we're going to be asking more of you. The internet has lots of advice out there on how to use machine learning tools, especially scikit-learn. Most of this advice is really poor, and some of it is just incredibly wrong. So use the net at your own peril. But in general, you should not rely entirely on net sources. You should be relying on also the lecture and the readings. And fundamentally, it comes down to you should be doing the coding. Going through that process is important to your education. And then the final point is, although this is an online format, I'm hoping that everybody is going to be asking lots of questions, whether that's in person during office hours or other times, or whether it's on the discussion board. Please do ask lots of questions. Part of a good problem-solving process is talking out different kinds of ideas. All right, so I'm looking forward to the semester, and I hope you are too.